Hi, this is Jeff Gorey, the Principal Investigator for the Transformer Toolkit Project. I am back again today with another video tutorial, so let's dive right into it. Today we're going to be talking about the Transformer Purchase Forecasting Guide, the Inputs tab. So this is called the Inputs tab, but what this tab is doing is it's collecting inputs, but it's also modeling the 71 years that we model in this here simulation. You'll notice on the summary guide, we're only giving you 41 years, but the reason we're modeling 70 is because one of the assumptions that we make is how far we're going to look ahead to gauge the projected load to size our new transformer if we have a failure. And right now the tool is set up for that maximum number to be 30 years. So with that in mind, this tool is wanting to collect some data. There are 4 columns that are salmon colored where we really want the data. And then there are 2 that are this white color, so it's not necessarily required. Going through these columns, I is just an index number. If you don't have an index number or some sort of unique identifier, just do, a series of numbers in order as you enter them. Second one is the size in kVA. Let's make that the correct way to write kVA. And then, service map location, equipment location. You can add columns here if you have more data. But yeah, and then there is the install date. The 2 big things this tool wants are install date and the size. And if you have those 2 things, this whole model will work pretty perfectly. The other thing that you can do here, it's kind of an interesting column. This was a recommendation from someone on the project committee. It's a peak load override. So the tool it's basically calculating what we think, how many homes are on this transformer based on the size. And then it's also calculating what we think the actual current load is. The way that you do that one is it's one of the values in the assumptions tab. It is assumed transformer reserve capacity at first year, basically saying how much space is left on the transformer. So, if the size was 10 kVA, it's going to model that base peak load as 9 kVA if you're saying that they have 10% reserve capacity. So that's how that works. But this column was invented basically like if you have load data, if you have past historical average monthly peak data, you can override that assumption by entering a number here. So let's enter 7. That's going to override this initial base peak load as it steps through the simulation years. So very handy column. Thank you to the project committee person who recommended that. So yeah, basically once you input that data, that's all there is with this one. If you're interested, you can kind of see what's going on here. This is year 0. So if that were 2025, it would be the 2025 to 2026 calendar year. It's kind of just setting things up. It's rolling your chance of having EVs based on the random numbers that we generate and also your current EV market share, this value here. And it's just stepping through the simulation, evaluating probabilities, rolling the dice, so to speak, and then reporting failure, pass-fail, basically. Yeah, I think that's pretty much everything that we want to say about this tab. I would also point out here that if you have more than 80 transformers, which is very possible, this tool can very easily accommodate that. You basically just need to pull down this bar and it should make it so nothing gets messed up. So let's just verify that here. I just did an Alt-WN for a second instance of the spreadsheet, just a new window. Let's go to the summary page. What I'm going to do is I'm going to do a Shift space bar. Actually, I won't because that'll include the whole spreadsheet. So what I'll do is I'll click this last cell here. I'm going to do Control and Shift, hold at the same time. I'm going to press the right arrow key until I get to the end of my table. You'll see that's, this last 71st year. And I'm just going to pull it down for however many transformers I need. Let's say it's, let's make it a number somewhere around 200. So when you first pull that down, you're going to notice that a little bit into your data here, obviously you'll need to re-enter in, the actual sizes of these here, actual install dates, all that. But you'll notice that there's a bunch of errors here in the numbers. The reason that is because as we re-roll our random numbers and we do the 6 simulations to average like what the results are, we control the size of our random number field so that the macro doesn't take days to run. The random number field is always optimized based on the number of transformers we have. So if you pull down there and you say, oh, it's all broken, I don't know why, the reason is you need to re-roll your probabilities. So we see our summary tab, it's all broken with those hashtag num exclamation points. Let's see what happens when we re-roll our probabilities. It's fixed. And so the reason that happens, it's intentional the way the tool is designed like this. It's meant to optimize the simulations. The number of transformers to be modeled is what determines the size of this here random number field. So it's 195 right now. It's multiplied by a number because we're getting random numbers for each column in our inputs tab. But basically the thing to know here is that as I go into the inputs, and let's say I actually only have 80 of these, so I'm going to delete the rest. You'll notice this number changes. It's basically just counting the amount of transformers that you do have. And so, yeah, that's just what you have to do if you're going to add a bunch of transformers here, is just re-roll the probabilities once you do. The way random numbers works in Excel, I'll just demonstrate this, is every time I edit another cell, it re-rolls this random number. And so that's why we have to have this big number field. Basically, there's a macro that does that rand calculation, a million times or whatever this is. And then it copies and pastes it as static plain text. So that's kind of why that is the way that it is. But it is a nice workaround. We've modeled thousands of transformers in this tool successfully. It just slows down a little bit for every 100 transformers you add. So that's why the example here is 80. I will also say, as you use the inventory tab, this old transformers here section right here, like if you have 20,000 transformers, you can sort of average those out using this tab here to get like a representative sample of your entire deployed assets in terms of transformers. And then you can, whatever the results give you on the summary, you can multiply that out. So that's another option if you have 100,000 transformers and you want to simulate without waiting days for the simulation to run. You could, there's probably you could use engineering as equation solver or some other more robust set of software that is designed for probabilistic modeling. But the thing is, the whole point of this tool is it's easily accessible to the average municipal utility worker, and it's easily used by the average municipal utility worker, hence why we chose Excel to do this modeling. So yeah, that is a brief overview of the Inputs tab. This is what gets everything going. In the next video, we'll start to go over the Assumptions tab. We'll probably do Assumptions and Summary as one tab because one feeds into the other. So I hope you found this video useful, and good luck using the tool.